Hi all. So we are in the practice assignment session for the course contents covered in week 8 of Signals and Systems course. Am I audible, guys?
Yes, ma'am.
Okay, let's begin the session for today. Question 1. An LTI system whose impulse response is right-sided and the Laplace transform is given by the following expression is dash. So here we are going to check the causality and stability of LTI systems based on their Laplace transform. Here the additional information given to us is the impulse response is right-sided. Can you guys try to solve this problem?
Uh, Causal but not stable.
Okay, yes, so you're right. So let's check the solution. Let's go through the solution once. So here the Laplace transform is given to us. How we have started is first we have found the poles of x of s. So our poles are s is equal to minus 1 by 2 and s is equal to 3 by 2. First thing that's given to us is the impulse response is right sided. So when the impulse response is right sided, it means that the ROC is right of the right outermost pole. So basically the ROC is greater than is s greater than 3 by 2. And when we are tending s to infinity, x of s tends to 0. So basically our ROC is right sided including infinity. So the system is a causal system outside the outermost pole, basically right side of the outermost pole. And then second thing is to check for stability, we basically check whether the ROC includes our j omega axis. Here the ROC does not include the j omega axis, so it is not stable. So the answer is causal but not stable. So we have to check whether the ROC is right sided, whether it is right of the rightmost pole, and then to check for causality, to check for stability, we see whether it includes the j omega axis. Moving on to the next question. An LTI system has an impulse response h of t with a pole at s is equal to 1 in the Laplace domain. Which of these statements about the system is true? So we don't know anything about h of t. We just know that in the Laplace domain, it has a pole at s is equal to 1. So what can we tell about the system with this information?
Definitely causal.
Okay.
Uh,
We don't know about the ROC. Like the ROC could be s greater than 1 or s less than 1 as well.
okay. So cannot be both stable and causal.
Yeah. So how do we approach this is as we told previously, we have a pole at s is equal to 1. So the ROC can either be left sided or right sided. If by chance we consider the ROC to be left-sided, we know that it is not causal for sure, but the system can be stable. Same way, if we know that if we consider the ROC is right-sided, that is, if we consider S greater than 1, it clearly does not include a j omega axis. So it is not stable. However, it could be causal. So simultaneously, the system cannot be both stable as well as causal. So the answer is option D. Okay. Moving on to the next question. What is the Laplace transform of del of t minus capital T?
Option A.
Okay, how can we, are you clear about finding the ROC here?
The signal is shifted right side, so S should be greater than 0 only.
Okay, actually, we don't find the ROC based on that. ROC, how do we find the ROCs? For what values of S does our integral converge? Okay, so that is how we find the ROC. For example, here if you see x of s, if it is minus infinity to infinity, del of t minus capital T e power minus st dt. So for what value of small t does this integral exist? Only when t is equal to capital T. So when t is equal to capital T, automatically, irrespective of whatever your s is, this signal is going to converge. It is going to have a value 1, right? Like this part is going to have a value 1. So it automatically becomes e power minus st. So this integral has no problem in convergence with respect to s. So the ROC will be all s. So for now, how do we find the ROC is for what values of s does our integral converge? That is what we have to keep in mind. So the ROC is e power minus s, the value is e power minus st for all s. Now, find the Laplace transform of cos of omega naught t into u of t. How can you write cos as e power j theta plus e power minus j theta by 2? So this into u of t is our signal. Basically, this theta is omega naught t here.
It is one standard, this one, so madam, so we can directly opt it for option D.
Okay, I'm just waiting for one more minute. So yes, the straightforward answer is, it's a well-known transform. So the answer is D. But how do you solve it? Like in a very fast ways. You can write cos of omega naught t as e power j omega naught t plus e power minus j omega naught t by 2. Now, if you take Laplace transform of these two terms, e power j omega naught t into u of t, we will be getting 1 by s minus a. So, if you see this, e power minus at into u of t. So, let us look into solving e power minus at into u of t, okay. So, e power minus at into u of t into e power minus st dt, right. So, here since we have u of t, this integral basically becomes 0 to infinity e power minus a plus s into t dt. So, if I have to solve this plus s into t by minus a plus s, where our limits go from 0 to infinity. Now, there is a catch in finding the ROC here. So, how do you say what is our ROC? If you consider this expression, for what value of a plus s does this integral converge? For example, if your a plus s is something negative, okay, if your real part of a plus s is lesser than 0, what happens? If it is lesser than 0, in the numerator it will become e power plus a plus s into t, right. If this has a negative sign, then this numerator is going to be positive, so e power plus a plus s into t, and then if you substitute infinity, this integral will diverge. So your a plus a, real part of a plus s has to be greater than 0 for this integral to converge. That is how we derive this ROC. So for this to happen, your real part of s has to be greater than minus real part of a. So that's what I told in the previous question. To find the ROC, you should find for what value of s does your integral converge. Is this clear?
Yeah, yes, ma'am.
Yeah. So now coming to this question, we have taken the Laplace transform 1 by s minus j omega naught plus, since you have a negative sign here, it will become 1 by s plus a. So it's 1 by s plus e power j omega naught, 1 by s plus j omega naught. So finally, if you solve this, you're going to get s by s square plus omega naught square. And the ROC is real part of s is greater than 0. Same way, what is the Laplace transform of sine of omega naught t into u of t?
Option B, the same way what you told for previous.
Yeah, right. So again, same way you can write sine as e power j minus e power minus j by 2j, e power j theta minus e power minus j theta by 2j. Same way, it's a straightforward Laplace transform expression. So if you solve, you will get omega naught by s square plus omega naught square, and our ROC will be real part of s greater than 0. Okay. So what is the Laplace transform of e power minus at into cos of omega naught t into u of t? When you have e power minus at into x of t, if you take Laplace transform, multiplication of exponential, what does it translate to?
The S domain will be shifted by A each. Uh,
Yes, so you're right.
so for the problem 6, it will be option D.
Yes. So when I have e power minus at, basically it's the same thing. Here instead of e power minus j omega naught t, e power plus j omega naught t, you will have minus of a minus j omega naught t plus e power minus a plus j omega naught t by 2 into u of t. Same Laplace transform if you write and solve, we will get s plus a by s plus a the whole square plus omega naught square. And there we had the ROC as real part of s greater than 0. Since we have e power minus 80, now we have real part of s greater than minus real part of a. So whenever we have e power minus 80, in the Laplace domain, it basically translates to a shift in s. So s plus a by s plus a the whole square plus omega naught square. Okay. So same way when I have e power minus 80 with respect to sine of omega naught t, again it's very straightforward. So basically you just have only a translation in s. So automatically we can say option B, omega naught by s plus a the whole square plus omega naught square, and again real part of s greater than minus real part of a. Now, the inverse Laplace transform of x of s, which is 1 by s plus a the whole power n, with an ROC real part of s greater than minus a is dash. What is the inverse Laplace transform of this? We've seen the similar property in Fourier transform as well.
Option B.
Okay.
D option is correct.
Yeah. So I'll just go through the solution steps again. So when we have e power minus at into u of t, the Laplace transform is 1 by s plus a. Now when you have a t multiplication by t in your time domain, t into e power minus at into u of t basically translates to minus d by ds of, that is differentiation with respect to s of whatever was the Laplace transform of this. So minus d by ds of 1 by s plus a. So if you differentiate 1 by s plus a, we will be getting again u by v. So when you differentiate u by v, it is v into u dash minus u into v dash by v square. So you will get 1 by s plus a the whole square. Now if I do t square, here again I have minus d by ds of whatever I have here. So it's something just like a chain. So for each multiplication of t, we have a minus one differentiation with respect to s. So for t square, it becomes 2 by s plus a the whole cube. So if I bring this 2 to the left hand side, so half t square e power minus at into u of t's Laplace transform is 1 by s plus a the whole cube. Now if I generalize this with respect to n, so here 3 is n, okay, so 2 is n minus 1. So 1 by n minus 1 factorial into t power n minus 1 into e power minus at u of t's Laplace transform is 1 by s plus a the whole power n. So whatever is asked in the question is on the right hand side. So our answer is this. Now we have y of s, which is given as x1 of s minus x2 of s, and x1 of s is 1 by s plus 1, x2 of s is 1 by s plus 1 into s plus 2. So what is the ROC for this y of s, where we also know that y of s is causal and stable? So we know what is x1, we know what is x2. So we can find an expression for y of s. And we know that y of s is causal and stable. So what is the ROC of y of s?
Sigma greater than minus 1. Option D.
Option D.
Okay. Um, can you tell what you got for y of s?
The poles we get is minus 1 and minus 2.
Y of s is 1 by s plus 1 minus 1 by s plus 1 into s plus 2, right? So if you see what is y of s, this s plus 1 into s plus 2 will come on the left hand side numerator. So s plus 1 into s plus 2 minus s plus 1 by whatever you have here. So your s plus 1 terms get cancelled. So what is there in y of s is just 1 by s plus 2. So we should not consider the poles of both x1 and x2. So even though you have a pole at s is equal to minus 1, in y of s that does not get reflected at all. So your y of s is 1 by s plus 2 only. And I think the others, you guys were right. So when your pole is just minus 2, your ROC is sigma greater than minus 2. That is, if y of s has to be causal, we know that the ROC is right to the rightmost pole. And here we just have one pole, so ROC is sigma greater than minus 2. And to be stable, the ROC must contain the j omega axis. That also is satisfied by this. So your sigma is greater than minus 2. This is just a small trick. So if x1 and x2 are given, first you find what is y of s, what is that fraction, and then with that, if you take the poles and then you use the information that's given to you, you can get the answer.
Madam, this calculation is normal mathematics, like we can do it, no, ma'am, like taking LCM. There
Yes,
is no
yes. Yeah, actually here it is not given. I mean, it's given in a very what to say, big manner. Basically, it is s plus 2 minus 1 by s plus 1 into s plus 2. That's all. So directly your s plus 1 term gets cancelled, right? This is the LCM, right? 1 by, I mean,
Okay.
x1 of s minus x2 of s. So
Yes, ma'am.
it's just x plus 2 minus 1 by s plus 1 into s plus 2. So
Yeah.
numerator you just have s plus 1. So s plus 1
Yes.
gets cancelled. Yeah, here I think this is a very wrong way of doing it. It's not that.
Okay, okay. And ma'am, we got the same answer for this one.
Yeah.
Okay, thank you.
Okay. Moving on to the next question. Determine the Laplace transform for y of t, where y of t is x of t minus 3 and x of t is cos of omega t into u of t. So we know what is x of t, and we saw what is x of s also today. And there is a translation in the time domain, x of t minus 3. So what does this correspond to in the Laplace domain? That's the question.
Option B is correct.
Okay.
Option B.
So what is the shifting property of Laplace transform? If I have x of t minus t naught, it basically translates to e power minus t naught into s, x of s. So if you use that property, we know what is x of s, s by s square plus omega square, and e power minus t naught into s is e power minus 3s here. So the answer is option B, you guys are right. Okay. Same thing, but now there is a scaling. X of 80 is there. So what does its Laplace transform correspond to? A is 0.5. So, yeah,
C.
yes. So x of at means it is 1 by mod of a, x of s by a. So,
Op-
yeah. So x of 0.5 into t, what does it translate to? 1 by mod of a, x of s by a. So instead of s, you have x by s by 0.5. So it is 1 by 0.5, which is 2, and then omega by s by 0.5 the whole square plus omega square. So here this is 4. 1 by 0.5 the whole square is 4. So 4s square plus omega square is the denominator. So the answer is 2 omega by 4s square plus omega square. The property is, if I have x of at and if I am going to take the Laplace transform, it's 1 by mod of a into x of s by a. So this is what we have to remember. Moving on to the next question. Determine the system for ROC 1 shown in the figure. The ROC is right of the rightmost pole. This one. This is our ROC.
Causal and stable.
Can you repeat?
Causal and stable. A
Yes.
option
Yes. So the ROC is right of the rightmost pole, and it also contains the j omega axis. So we know that it is causal and stable. Yes. Okay. Now determine the system for ROC 2, that is minus 2 less than sigma less than minus 1. What is the kind of system?
Neither causal nor stable.
Yes. So the ROC does not contain the j omega axis, so it is not stable. And the ROC is not completely right sided, it's basically two sided, right? So it is not a causal signal. So it is neither causal nor stable. So it does not contain the j omega axis, so it is unstable, and it's a bilateral signal, so it's not causal as well. Now determine the system for this third ROC.
Neither causal nor stable.
Yes, it's the same thing. It does not contain the j omega axis and it's a left-sided signal. It is left, the ROC is left of the leftmost pole, and hence it is neither causal nor stable. Okay. Now we have a system y of t is 3 e power minus 2t minus 2 e power t into u of t. Determine the ROC such that the system is unstable and non-causal. So with this y of t, you guys have to find y of s. And you have to say the ROC for that y of s such that the system is unstable and non-causal.
Sigma greater than minus 2. Sorry, sigma greater than 1.
Okay,
Option B.
I'm just giving one more minute for this.
Sigma less than minus 2, ma'am.
Yes, that's the thing.
Option C, ma'am.
Yeah. So y of s, as we know, it's again straightforward. So it's 3 divided by s plus 2 minus 2 divided by s plus 1. So it's same e power minus 80 into u of t, same formula. Now if we have to find what is y of s, we get 3 into s minus 1 minus 2 into s plus 2 by s plus 2 into s minus 1. So if we solve this, we get s minus 7 by s plus 2 into s minus 1. Basically the poles are minus 2 and 1. And for it to be unstable, it should not contain the j omega axis. So definitely it has to be on the left side. And it is non-causal also. So it has to be a left-sided signal. So the ROC should be left. So we have sigma less than minus 2. So in this session, I guess you guys had almost a fair idea about ROCs and how do we determine the stability and causality of the system based on the Laplace transforms.
Yes, ma'am.
Do you guys have any doubts in these things?
No, ma'am.
Okay. And actually I will share this with you in the website. Basically, we can't find the Laplace transform in MATLAB as well. So the formula to find the Laplace transform is Laplace of x. So if I am giving some input, say the input what I have given is, one second. So the input what I have given is e power minus 80 into u of t. U of t here we will write it as heavy side of t, okay. So e power minus 2t into u of t is our input that is being given, e power minus 2t into u of t. We know that the answer, the Laplace transform is 1 by s plus 2. So if I write Laplace of x, I will be getting 1 by s plus 2. So the function to find Laplace transform in MATLAB is Laplace of x. Like this, you can find the Laplace transform of any complicated functions also. So if you say you're solving a problem, okay, a big x of t you have, and then you're solving, you found the Laplace transform. You want to check whether the Laplace transform what you got is correct. Then what you do? Then you open Octave or you open MATLAB, and then you give x, you give input x of t, and then you say find the Laplace of x. It will give you the Laplace transform. You can verify your answer like this. And to find the inverse Laplace transform, you have to give I Laplace of x. I stands for inverse. So I Laplace of x, if we do, we will be getting the inverse Laplace transform. So here what I did is, this capital X is there, right, 1 by s plus 2. I gave that as input to I Laplace directly. So what I got in x cap is e power minus 2t. So basically what I gave as x of t is what I got as the output also. So to find Laplace, Laplace transform, we have to use Laplace of x. To find inverse Laplace transform, we have to do I Laplace of x. So this is the first part. Now say you have a transfer function, that is you have some x of s, okay, and then you want to find the poles and zeros of that x of s. How do we do? That is the second part. So here we have to, what I've got is input, enter the numerator of the transfer function as an array. So the numerator I have given as 1. The denominator I have given as 1 space 2. Okay. What does this mean? So whatever I am writing in first is the coefficient of s of 0. And then whatever I am writing second is coefficient of s power 1. Like this, from the right hand side, whatever you write, they are coefficients of different powers of s. For example, let us see an example. I have s square plus 2 divided by 3s cube plus 2s square plus s plus 1. Okay, this is our transfer function. So how do we write it in MATLAB? How do we express it? Means for numerator I will be writing 2 first, and there is no s term, so it is 0, and then s square la the coefficient is 1. So I will express s square plus 2 like this. So from the left means it means the higher power of s, okay. So for s square the coefficient is 1, there is no coefficient of s, so that is 0, and s power 0, that is the constant term, it is 2. So this is how I will express my numerator. How I will write my denominator? So s power 0 constant term is just 1, s term la coefficient is again 1, in s square term coefficient is 2, s cube term coefficient is 3. So this is how I will write my denominator of the transfer function. So from the left, if you see there, it represents higher powers. So this is a power of s cube, then s square, s, and then constant. So in this manner, if I am going to give the numerator and denominator of the transfer function, I can get the poles and zeros by using PZMap function. PZMap, pole zero map. Okay. Here, let's see what is that I have given as input. 1 and then 1 space 2. It means the transfer function what I wanted to write is, in the numerator it's just 1. The denominator is 1 space 2. So 1 means the coefficient of s is just 1, and then the constant term is 2. So this is the transfer function I wanted to give as input. So can you guys tell the poles and zeros of this? There are no zeros, and the poles are just one pole is there, which is at -2, correct? So if you see this PZMap function, whatever I have given, it has returned the poles and zeros for me. Poles I have got -2, zeros it has told that there are no zeros. It's empty vector. So like this, for any complicated transfer function like this, whatever I've shown you, s square plus 2 by 3s cube plus 2x, some a very big transfer function also, if you give in this format, first you have to give the numerator in array form, and then you have to give the denominator in another array form. So after giving these two inputs, you have to write h is equal to TF of numerator comma denominator. TF stands for transfer function. So if you give this line, your h now becomes a transfer function with this numerator and with this denominator. And then if you write PZ map of h, you will be getting the poles and zeros. And to use this TF function, PZ map function, you have to have the control systems toolbox in MATLAB. So it will come as some add-on. So you have to install that, and then only you can use this TF and PZ map functions. So MATLAB or Octave, they are computing software. So for any complicated signals, we can find the Laplace transform, inverse Laplace transform, the poles and zeros of the transfer functions in MATLAB easily. This is just to give a feel about MATLAB, okay? You guys might not need this for your exam, but still, this will help you in your future works.
Madam,
Yes,
this for numerator and denominator we are writing for quotients of s, no ma'am.
yes.
So is there any option that directly it will take from whatever it has calculated?
From this, for example, like 1 by s plus 2,
Uh,
from this directly. I'm not sure if maybe there are some functions, but I'm not sure about that. I use this kind of format. Like it's easy,
oh,
right? Based on the coefficients of different s, we will just put them as one array.
okay, ma'am.
Yeah. So is anybody having any doubts? One second, I got some message in the chat box, I suppose. Okay, nothing. So is anybody having any doubts? Okay, if not, I think we can end the session for today. Thank you all.